So thanks very much for this last presentation. So perhaps I'll just start off by pointing out the obvious challenge to our region, which is to settle, effectively 200,000 people here in the next 20 years, that kind of thing, to have a sustainable economy and to preserve our natural environment altogether in the face of significant challenges like climate change. So our university, the University of the Sunshine Coast, and the Sunshine Coast Council are working together in a partnership project to dig into, in more detail, natural assets and natural asset values, and the complex relationships between those values and the flow of environmental goods and services to people and different beneficiaries, relationships between different sections of the economy, for example, tourism and agriculture, the relationship between streetscape level environmental attributes like trees that provide local habitat and increase our housing values, and then the big landscape level ecological processes and values. So I'm going to cut short my comments here and hand over to the rest of the team. But this particular part of the project that we're presenting on today has a different lens on the landscape, and it's really, instead of looking at biodiversity, which of course Council has done some great work recently on their biodiversity report and so on, or other artifacts in the landscape, this is really much more of a view of ecosystem functions, biological, production functions that are occurring in the landscape. We've heard reference to them earlier on in the presentations. For example, Mike Ronan earlier on talking about the relationship between vegetation on slopes and water infiltrations and the flow over land and so on. So we have these functions that are occurring: soil formation, soil retention, buffering effects from extreme events, as this would be occurring with Bribie Island and so on. So this particular view that we'll be presenting here is some of our research on mapping those ecosystem functions, which are the precursors to the ecosystem services that we receive and that we benefit from. So I'll turn over to Simone Maynard, who's an expert on ecosystem services, and also Naomi Forrest, who's now, I can say, an expert on mapping ecosystem functions. She's a final year environmental science student who we gave the task of doing what has only really been done once before, a highly complex mapping process. And thanks to Shannon Mooney at Healthy Land and Water, we've got some really interesting initial results to present.
Okay, so when we came into doing this project, there's an old saying, if you can't measure it, you can't sustainably manage it. So we wanted to look at the values of natural assets in the Sunshine Coast region. We went looking for a tool that would enable us to do this. So in 2005 to 2011, stakeholders from across the region, state government, local government, federal government, industry, business, community groups came together to develop and agree on a framework for identifying, mapping and valuing ecosystem services. It was called the SEQ, Ecosystem Services Framework. And it was developed through a whole range of expert panels and think tanks and community workshops that, looking around this room, I can see over a dozen people that have been involved, in the development of this framework. Underpinning this framework, when we had to look at what sort of information was required to actually do an ecosystem services assessment, the stakeholders said we need to understand the ecosystems in the region. What ecosystems exist. So we needed to understand there was seagrass, there was rainforest, there's beaches, that all of these different types of ecosystems, there's urban ecosystems, there's agricultural ecosystems, they all perform different ecological processes or different functions. And these ecological processes and functions are important for self-regulating these ecosystems, regardless of whether people care about them or value them. They're important for regulating nature and ecosystems for their own sake. But people do care and value about many of these. And when people care and value and receive a benefit from these, we get these ecosystem services. And we know that ecosystem services contribute to human well-being. So this is the framework in a very quick nutshell. There's three main elements to it. You can see those four components for assessment, those ecosystems, functions, services, and human well-being. In fact, the experts came up with 32 groups of ecosystems, 19 critical functions or processes occurring within and across these ecosystems, 28 ecosystem services, these good things, 28 good things that we get from the environment, us as people, were identified for this framework, and they contribute to what the experts identified, 15 constituents of wellbeing. So it's one thing to identify these and describe these, but we need to understand the interactions between these. So then we ran these expert panels and we had these series of matrices and scores of 0 to 5 that rate the relative magnitude between each one of those ecosystems and the different functions and the functions and the services and wellbeing. And then, of course, we're developing a decision support tool. So we want to spatially identify where in the landscape these ecosystems and ecosystem functions are and where they're being performed. And so these elements of the SEQ framework have been what we've been working on in the Sunshine Coast here to develop a form of Sunshine Coast ecosystem services framework. So we've been localising or downscaling this framework specific to the Sunshine Coast region. And, whoops, going the wrong way. So because we actually have that information, we can actually develop these sorts of models. And this is one for coastal zone wetlands, but we can put these together for rainforests, for seagrass, for agricultural systems. And we see here, and I'm going to stop here, but I just want to draw your attention to the right-hand side. And these arrows are just some of the high scores, those 5s that the experts gave in those workshops. And they said coastal zone wetlands as the ecosystem is important for performing the function disturbance regulation, which Naomi is going to take you through in the next section of our presentation. And because this disturbance regulation is occurring across the landscape or from these coastal zone wetlands, it buffers us as people from extreme events. It also, because this buffering against extreme events is occurring, well then we get security of health and we get social and economic freedom and we get community and social cohesion from this. And as I say, we can develop these models for all the different types of ecosystems in the region. But Naomi's going to show you some of the spatialising that we're doing with a specific focus on the disturbance regulation.
Thanks, May. Hey everyone. The GIS project team were tasked with mapping the 19 ecosystem functions that were initially designed to support the SEQ framework using the Petter et al. Methodology. This approach provides support to identify where ecosystem functions may be being derived from in the landscape. Our purpose was to localise the maps to the Sunshine Coast region and produce the 19 maps along with a final total function map that will support and add value to current planning and management strategies. Got the right way. So 60 data sets were reviewed by experts, including the Sunshine Coast Council and Healthy Land and Water. Each data set represents a different pathway in which an ecosystem function can be performed. The maps were produced by overlaying the selected suite of data sets that combined and in different combinations would represent each ecosystem function. To provide context and meaning to each map, the data sets were localised by substituting state and regional scale data with more relevant Sunshine Coast data sets. In total, 25% of the data was substituted with local scale data. Where there is overlap of data sets within a function, it provides greater confidence that the processes and pathways for ecosystem function are being performed in the landscape. Oh, sorry, I'm just going to go back to that slide. So the disturbance regulation map that Simone talked about earlier. So disturbance regulation is the capacity of the soil, regolith and vegetation to buffer the effects of wind, water and waves by water and energy storage capacity and surface resistance. So this area, minimises flash flooding, storm surges, excess runoff and whole other range of regulating processes that are related to our highly variable weather. As Simone mentioned, some of the ecosystem services it contributes to are buffering against extremes and also keeping a habitable climate. And I think we've really touched on this topic today with, some of the projects that the community's been doing. So 15 data sets were applied to this map, and it shows you there that 10 data sets offer the highest overlap. So this is giving confidence that this ecosystem function is being performed in the landscape and can be represented in the dark blue, which you can see if we zone in on the Pumicestone Passage catchment. Areas like Bribie Island and the Ramsar wetlands offer the highest data lap and potential for ecosystem function to be performed. I just want to note as well, some of you will probably notice that there are low values showing along the coastal zone. One of the limitations of ecosystem function mapping is data gaps, and this is evident along that coastal layer being represented as a low value. What this methodology does allow for is the flexibility. It's an iterative process, so you can update the maps and as technology and data sets become available. So this is a final total function map. The final total function map provides an overall spatial analysis of where there is potential to provide a full range of ecosystem services in the landscape. The total ecosystem function map is an interaction of all the 19 function layers. So all the 19 functions are then overlaid together to produce a final ecosystem function. The areas shaded in dark green represent the highest data overlap, and this gives confidence that a high level of ecosystem function is being performed in the landscape. So again, you can see areas, I won't use the pointer thing, I probably won't be good at that, but areas that are dark green are largely the natural areas, again, as we would expect in the Pumicestone catchment. But what you can also notice, peri-urban areas, around the Biawat area, and more built-up environments do have pockets of high overlap. And I think this is really important to point out because they are areas that we can also value and protect as they offer ecosystem services. Oh, thanks. So our maps demonstrate that ecosystem function plays an important role in ecosystem service assessment and are a useful tool in determining the linkages between ecosystem functions and the services they provide. At present, our next steps will be to ground truth the maps through expert review and stakeholder engagement. And by localising the function maps, local government and catchment managers have the opportunity to integrate these spatial tools into land use planning and strategic management of natural assets. And I would just like to finish up and say, as a third year student at USC, it's been an amazing opportunity to be part of this project and also present here today. I've heard some amazing community people doing some great work, and it's also been really exciting to be part of this. My next step in this research will be to take the function maps and look at climate change modelling and see how those functions may perform under different climate change scenarios. So thank you.
Well, we've got one question from the Mentimeter, which I presume is rhetorical, that asks, what about ecosystem disservices? So there you go. Would you like to answer that, Graham? Okay, there you go. Graham's going to answer that one. Just a couple of minutes there.
Listen, I think Simone would be better for this, but of course there's ecosystem disservices as well. That could be something like mosquitoes. So then we have these trade-offs. Certainly when I saw the images of the salt marsh and recalled our trip down there, thought about some of those ecosystem disservices as well. But I think the main point to take across here is it's a different way of looking at the landscape, a function perspective that leads to these services rather than always thinking, assets and so on. So we think about mangroves. Mangroves are a certain species, but they are providing fish habitat. They're providing this buffering effect. So instead of looking at it from the tree perspective, we're flipping it around to look at the function perspective. And when you do that, you get the interesting view on the landscape that you can see, is there, if for instance, then we can consider different planning scenarios and so on and say, what would be the impact of that land use change on the representativeness of these different ecosystem functions in the landscape? So we can look at, for instance, Golden Beach, it would have a ecosystem function profile that would be different from, somewhere like Mullany and so on because of the nature of the environmental attributes up there. So it allows us to undertake investigations in different ways to see. In fact, we were quite heartened when we looked at did some work, just very early work with council and compared the conservation estate to the areas of high ecosystem function and found there was immediately an 85% overlap between those. So different ways of investigating, important functions and services in the landscape.
Fantastic. Thanks, Graham. Clap there.